Hi everyone, and welcome to the flipped instructional recording for 3.02 chemical reactions. Just as a reminder, make sure you take notes during the recording. I'm going to highlight some important things that you'll want to add. And remember that you are making a new slide for this lesson, and you want to change that lesson number and title. So we look at the sample slide here. You can see up here, don't forget to change 3.02 chemical reactions. Remember, your notes go on the left. These notes, you can tell they have a lot of pictures. I think it's just for appearances in the lesson as a sample. You can't really get a lot of information out of these notes. There's a lot of pictures. So if you're taking a quiz or a test, looking at that really wouldn't provide you a lot of information. Also, remember your guiding questions go over on the right-hand side. So we will jump in and get started. All right, as we get into the lesson introduction, we're talking about chemical reactions. Have you ever seen or lived in a house that uses propane instead of natural gas or oil? People who live in rural areas often heat their homes and fuel their stoves with propane. Propane reacts with oxygen to produce heat, carbon dioxide, and water. Keep reading to find out how bonds are broken and new bonds are formed in this simple chemical reaction. All right, so we take a look at the lesson goals. Remember, this does not need to go anywhere in your notes. But there are a lot of vocabulary words that you do want in your notes. There's a lot of important words here. So combustion reaction, it's an exothermic reaction in which oxides are usually formed. A decomposition reaction. So that's a kind of chemical reaction in which a single compound is broken down. The way I remember decomposition is the word decompose and breaking down. So it's into two or more simpler compounds. An endothermic reaction is a chemical reaction in which energy is absorbed. So when you think of absorb, you think of taking something in, and I remember that with the en beginning, endo. So taking something in. And with exothermic, we know that heat is being released. So I think of the word exit and heat being or energy being released. A precipitate, this is something that's kind of hard to wrap your head around. It is a solid that forms as a result of a chemical reaction. So a white solid precipitate may form when aluminum chloride is added to a substance that contains aluminum. So this part is really just an example. The definition you need is a solid that forms as a result of a chemical reaction. And then products are the molecules that result from a chemical reaction. So products, I think of the word produced. So it's what's made. It's on the right side of a chemical reaction. The reactants are the starting molecules in a chemical reaction. That's what's on the left side. Okay, so we got those key words in and we're moving on. Again, I always like to take a screenshot of the guiding questions so that I make sure as we read along, we are finding the answers to those. So these are nothing that need to be Googled or whatever. They're so easy to find. They're right in the reading. So the first thing we need to look for, guiding question 1 says, what happens during a chemical reaction? So here's our first slide. Think about the propane stove example. When you turn on a propane stove, propane reacts with oxygen to form different compounds. In the model at the right, you can see that bonds break between reactants and then form again to create products. This process of breaking down and forming bonds occurs in a chemical reaction. So that's your answer to guiding question number 1. What happens during a chemical reaction? So it tells you right here, bonds break down between reactants and form again to create products. Okay, so breaking and forming bonds, that's what happens in a chemical reaction. So we already defined reactants. So this gives you the formula. Propane is C3H8 and oxygen gas is O2. They have different properties than the products. So that's what's produced, right? What's produced is carbon dioxide, which is CO2, and water, H2O. The resulting products are different compounds than the reactants, and they have their own distinct properties. The properties of the reactants and products are different because a chemical change has occurred. So if we're looking at this image here, we have carbon is black, hydrogen is white, oxygen is red. So the reactants, what we're starting with, are propane, C3, H8. So you can see the 3 carbons. And then oxygen, we have those 8 oxygen molecules. So that's what we're starting with. The chemical reaction occurs. The bonds break. That means everything's kind of released. And then we have what is produced. So that means products are water, H2O, and carbon dioxide, CO2. So the H2O are these with the little white, and then the carbon CO2 is, remember, with the black. So that gives you an idea. You can visually see the beginning and the end and how those are different. Exothermic reactions release energy. So we talked about that. Energy is always involved in chemical reactions. Propane and oxygen gas need energy to react. They need a spark to get a reaction going. During the reaction, heat and light are released, as well as carbon dioxide and water. Heat and light are forms of energy. This type of chemical reaction is called an exothermic reaction because it releases more energy than is needed to get the reaction started. The energy released as heat is used to heat a house or to cook food. If a chemical reaction occurs in a flask, so if you think about like a science tool, the little glass, and the flask becomes warm, then was the reaction exothermic, and why? So if it is warmed, yes, the reaction is exothermic because it released energy as heat, and so that's why that glass would feel warm. So you can see an example here. Heat and light are produced. Endothermic reactions absorb energy. So you just learned about reactions which energy is produced along with products, but some reactions need energy to keep them going. When energy is broken down into hydrogen gas and oxygen gas, it requires energy to keep the reaction from stopping. The energy is absorbed to break down the water and form products. This is called an endothermic reaction because it absorbs more energy from its surroundings than it releases. If a chemical reaction occurs in a flask and the flask becomes colder, was the reaction endothermic or exothermic? So hopefully at this point you're saying easy, endothermic, because we know it got cooler and it absorbed more energy than it released. All right, so combustion reactions. When you strike a match, the element sulfur in the match bonds with oxygen to produce sulfur dioxide and energy in the form of light and heat. This type of reaction is called a combustion reaction. A combustion reaction is a reaction in which a substance combines with an oxygen or with oxygen to produce a lot of heat and light. The burning of propane is a combustion reaction because the propane reacts with the oxygen molecules in the air. It produces light and heat. We get energy from fuels as a result of combustion reactions. So this would be where in your notes a picture might be helpful. If you have your definition for combustion reaction and you drew maybe a match with a flame, that would maybe signal to you, heat is being produced, a lot of heat and light. So burning of propane or something like that, it's reacting with the oxygen in the air. So the combustion reaction and producing heat, that might be a good picture to add in. So is a combustion reaction an endothermic or exothermic reaction? So you might be confused, like, wait a minute, can they be one of those two things or is it their own thing? But they can be classified as one or the other. And we know if heat is being produced, it is exothermic. All right, decomposition reactions. Remember, this is breaking down. So another kind of reaction is called a decomposition reaction. In this reaction, a compound is broken down into two or more similar compounds. Decomposition reactions can be endothermic or exothermic. The diagram at the right shows the decomposition of water. So it might be good to put in your notes that decomposition reactions can be both of these. That would be helpful. So we're breaking down water over here. The water is broken down into hydrogen gas and oxygen gas because the reaction results from passing an electric current through water containing some ionic salt. The reaction is called electrolysis. You may have heard that word before. It is an endothermic reaction because energy from the battery must be continuously supplied for the reaction to take place. So if you see an energy source, that's a good indicator that it's endothermic. The products of the electrolysis are hydrogen gas and oxygen gas. These gases can be compressed or even cooled to become a liquid. So they can be used as a fuel. Hydrogen gas burns in air to produce pollution-free product water. And the oxygen gas can be used as a source of oxygen gas for various medical and industrial purposes. So why is a rotting tree considered a decomposition reaction? Okay, you may have not seen a rotting tree before, but you've probably seen rotting fruit. I know that happens at our house quite often when my kiddos don't finish like the strawberries or the blueberries for the week. You see that breakdown. So what happens? In the case of the rotting tree, the tree is being broken down into a simpler substance which are absorbed into the soil. The tree is more complex than its products. Okay, so it is reacting with the oxygen in the air and breaking down. So you can watch the video here, just the simulation. It's very, very short. It's showing the formation of hydrogen bubbles and oxygen bubbles. All right, so this is a great way for you to just practice with these words, make sure you understand, the difference, the definitions, just by placing those. So that's a great practice activity. All right, so now we're talking about the forming of a precipitate, and these are pretty cool experiments. So one of the most dramatic chemical reactions is shown at the right. So the reactants are lead nitrate and potassium iodide, which combine with each other in a chemical reaction. The bonds in each reactant break down and other bonds are formed. A bright yellow color is produced. So you can see that in the picture they have lead nitrate and it looks like potassium iodide. So those are two clear liquids, but when they are combined together, a bright yellow precipitate, lead iodide, is formed. So that is a solid that has formed from mixing those two liquids together. So that visual may be helpful for you to put in your notes. You may want to take a little screenshot of that picture. And it's due to the formation of a solid, again, lead iodide, and that formation of this precipitate indicates that a chemical reaction has taken place. A substance that separates in the form of a solid, basically solid particles, from a liquid is called precipitate. So indicators of a chemical reaction. How can you know when a chemical reaction has occurred? A chemical reaction can result in the formation of a precipitate, so we might see that. Formation of a gas, we usually see that if something bubbles, we know that it's releasing either like hydrogen gas, oxygen gas, so that's a good, easy indicator. Or sometimes we see a change in color. The release of heat or light can also indicate a chemical reaction. So I would write down all of these things. How do you know a chemical reaction has occurred? Result, I would say formation of a precipitate, formation of a gas, change in color, release of heat or light. So all of those things. The observations are called indicators of a chemical reaction. So those are called indicators. So you may just put out to the side a big arrow pointing. All of those things are indicators. They don't guarantee that a reaction has taken place, but if you see one of these changes when you mix chemicals, you're alerted that a reaction may have occurred. Don't be fooled. A chemical reaction has not occurred when you see these things. So when you see fizz, when you open a soft drink, that's not a chemical reaction because the carbon dioxide gas was already there and it's just dissolved. When you mix yellow and blue solutions to get green, the pigments in the yellow and blue make green, but really no chemical reaction has taken place there. When you put water in the freezer and it turns from a liquid to a solid, we know that's not a chemical reaction because the ice is still water, it's still H2O, so that is not a different product formed. So phase changes are not chemical reactions. You should put that in your notes as well. All right, as we get to the last slide here, this is a great system check here to make sure you understand, is it a chemical reaction or not? So these are very good practice. All right, and as we move on, we're checking our knowledge, but if we look back at the guiding questions here, very easy. We know an exothermic reaction gives off heat. Give an example. We talked about, heating up anything. Endothermic reaction is absorbing heat. Okay, so you can look back in the lesson and find that example there. A combustion reaction, is a combustion reaction endothermic or exothermic? Remember, we said on that one, it's exothermic because it's giving off heat. And what happens during a decomposition reaction? We know that things are being broken down. We saw that in the lesson. What does the formation of a precipitate indicate? Pretty easy, right? We saw a solid form as a chemical reaction. And then what are the indicators of a chemical reaction? So you just had that in your notes. You have formation of a precipitate, a color change. I'm trying to remember what the other one was. Remember, we just wrote those down. Endothermic, exothermic reaction. So make sure that you answer all of those. There are 7 there. And then take a look and go through these as well. Good little practice problems. They take just a second. So that gets us through the entire lesson with notes and guiding questions answered. So with that, if you have questions, anything else that you might need help with, you can look for a flip follow-up session, come to a help lab, or message me for some extra help. Have a great day.